Hello, welcome to this new tutorial on Java. So yesterday we discussed about the array list, which was the one of the classes in the Java collection framework. So in this tutorial series, we are discussing about the Java collection framework, which is used to provide a set of utility classes to operate on a list of objects or list of things. And yesterday we tested on the array list. So today we are going to discuss about another utility class which is called LinkedList. So this also implements the list interface which we discussed yesterday. So if you have not seen that video, please go back and check that video on the array list and the list interface. So as you know, yesterday we had that array list, and we knew that array list is used to store the values in ordered way in a list when you really want to do just the storage and navigation of those elements. But if you want to do the manipulations on those are like costly operations on the array list. So in order to in order to fix that problem, and there is this new structure available, and that's called linked list. So we're going to take the same example what we did yesterday. So we're just going to do today with the help of a linked list actually. So let's see. So we're just going to declare a new linked list here. So let's see, we have to import this is from the utility. And we created this new linked list object which is of type, it contains objects of type string, but in reality it doesn't have to be string, it could be any kind of objects, Java objects, which may be more complex than just a string, because string just represents one thing. Let's say it represents the name of the car. This is a string, this is a string, but in reality this type, that's what we call it, type in this less than equal to sign and less than greater than sign. This is the type. So it could be anything, it could be any kind of Java, complex Java objects. So but for this example we are just using string here. So before we go too much into this one, so let's see, let me just show you one example. So this is the way linked list will look like. So if you see, this is called a node, actually, this box. So you see it has a data. I store a here, and there are two parts to this node, this whole block. There's the value which is stored, a, that's the data or value, but there's another box here, second box here, and we said next. So what this does is this stores the address of the next node in the list actually. So as I mentioned, the array list stores all the records in contiguous locations, but the linked list doesn't store everything together in memory. It's not a if there are 10 nodes in this linked list, all of them are not stored at the same place in memory. They're stored all over place in the memory. They're not next to each other. So that's why when we store the first node and we put the second node, we also put the address of the second node in the first node here. So this box is nothing but it's the address where the second node is stored. So second node B is stored here, and now the B will also store the address in this field where the C node is stored, and the C will store the address for the D node, and the D node is the last node in the list. There's no other nodes. So that's why the next of this, this is the next block, it will just contain null. So it means this is the end of the list. There's nothing more after this. So this is the way it is represented, linked list. So it's a dynamically growing list, and the nodes are not stored in the contiguous locations. They're scattered all over in the memory, but each node contains the address to the next node, and the next contains to the next node, and the last node doesn't store any address. It just says null. It means that's the end of the list. There are some conventions used. The first node of the list is called a head. That's why it says head. So when you want to traverse or loop through a list, you need to know that first node. You need to know the starting node. Otherwise, you won't get anywhere. So you need a starting place. Then after that, this first head. Then you can always go to the next. to the next, to the next, and then when you encounter the next is null, so it means it's the end of the list. So let's suppose you want to create a new node here called, let's say you create a new node here called E. Let's say you create a new node called E here. I'm just giving an example. Then what you will do is, when you create this node in memory, there will be address of this node. So what you will do, you will assign that address to the d.next here. And so what will happen then, now d will point to E, but on the E, the next node or the address for the next node will be null, because that E will be the next null in that case. I mean, it will not point anywhere, it's the last node actually. So this is a concept of a linked list. So what happens, the Java provides the utility classes to deal with linked list. But if you go for like any kind of Java interviews, they also ask you, oh, how will you implement your own linked list without using the Java utility classes actually? So in that kind of scenario, so I think I might go in the future some of the videos on that one, how to do that yourself. But then it means you have to really do the implementation of this linked list class yourself. But for doing your programming in Java, this class is already available, so you can just make use of them actually. So that's why this linked list is already available. It knows how to add elements and how to remove elements, everything is there. But in reality, when you go to like interviews, they may ask you, oh, how do you even implement this linked list actually? So but that's a totally different topic, not part of this tutorial. So let's go here. So let's say you added A here, and you can keep adding here elements. So this is very similar to the one like yesterday. They're not much difference. The only difference is how these elements are really stored in the memory, and how is their performance, those kind of internal implementation. That's the only one difference, but otherwise it looks pretty much like an array list actually. So you got everything here, so you can just say, let's say you want to print this list actually. So I just call it cars, but I just put ABC. So you see A, B, C, D, all of this there. So let's say you want to remove, or you want to, let's say you want to add a new element, and you say you want to add an element at so this location 0, 1. Let's say you want to add element at location 2, and you want called B2. I'm just giving it a name actually. So you can dynamically insert an element at a certain location. So if you see 2, so I said add element at location 2, so this is 0, 1. So 2 will come after B, so that's what it did. After B, it insert to this B2. And you can also do like remove the element actually. So either you can remove element at a certain index. Let's say I want to remove C. So we know that C is at 0, 1, 2, 3. It's at position 3. So let me just also print it again. So we are trying to remove C because C is at the position 3. Oh yes, so you see that C is gone. So this is one way of removing. So there's another way of removing. You can also remove the object itself. So let's say what's left. I want to remove B2. You can also put the object. So you see B2 is gone actually. And this linked list also has similar method what you had in the array list. You can find the size of this list. You just do the size method. It tells you how many. If you want to clear all the entries, you can use the clear method. If you want to see if the list has any elements or is empty, you can use this one. And all these methods are available. If you want to iterate through the list, you can use this iterator actually. So you can iterate through the list actually. So all these methods what you saw in the array list are also available in the linked list, but it's just your use case when you should use the one versus the other one. So as I mentioned, array list is good if you want to just store the stuff once and just navigate it or read through it, and you don't want to do any manipulation, then array list is good. But if you want to do a lot of manipulations, then you have to use the linked list, because that's good at manipulating the elements actually. And one other thing about this linked list is, let's say you want to go this element C. there is no direct way. You can't just get C. You can't do that. So you always have to start somewhere. So you have to go sequentially. So you start with the A, then go to B, then find C. So it's more like, you can't access the element directly. You have to navigate it from starting point, and then you keep going further, because otherwise you don't know where the C is stored in memory actually, because it's not an index 3, really, so you can you have to just navigate. You have to just start from here and just keep going like this, and just, that's the way to navigate this list actually. So I think for this tutorial, this is good for today. Maybe tomorrow we're going to touch on sets, and later on we also going to touch on the map, hash maps, and those kind of stuff. And there are quite a bit of stuff in this collections framework, but we're going to probably do only some of the simpler ones. There's other less used stuff we may not cover as part of this tutorial series. So I hope you enjoyed this video, and please like this video and subscribe to the channel, and I will see you in the next video. Thank you. Bye.